Okay, this is going to be a tutorial on choosing the components and soldering up the connections for a standard Telecaster style control plate that has a three-way blade switch and a master volume and a master tone, and will end up looking something like this. And obviously here's the output jack coming out. There's some decisions that you have to make. Even though this is quite a simple circuit, before you get going you need to make some decisions. So let's talk about that for a minute. Okay, let's talk about choosing the components for this Telecaster control plate. What you can see here is a standard Telecaster control layout for standard Tele pickups from Seymour Duncan, and you can get these on all sorts of sites online, obviously. Here's another one from Lindy Fralin from Fralin Pickups. Very similar, but if you look closely, the tone control is done a little differently. And if you don't have the background in electronics, some of this can be confusing. And I don't want to turn this into a huge electronics lecture, but maybe do some quick demystifying of choices in potentiometers for the volume and the tone controls and the capacitor value that you use. Okay, let's talk potentiometers. This confuses the heck out of beginning builders, and it's really simpler than you realize. First is there's no such thing as when you're buying potentiometers, a tone pot or a volume pot. There's just potentiometers. There tend to be two for electric guitars or basses. There tend to be two nominal values that you'll hear tossed around, 250K pots and 500K pots. The choice is really driven by two things. Ultimately, it's really driven by what you want to hear in your ears. But is whatever pickups you're using, is take a look at what the manufacturer recommends. They obviously want their pickups to sound as good as possible. So if they're saying, well, we think you should use 250K pots, then try 250K pots. If they say, well, we think you should use 500K pots, use 500K pots. The reality is they are never, if for example, these two are supposed to be 250K pots. Neither of them is actually 250K. They're both slightly different. And this was a 500K pot, and this one's, I wrote right on there, 524. I always check. One is just to make sure the pot's okay. But typically, they're about 10% plus or minus. So you can imagine with a 500K pot, 10% means it could be as much as 550 or as low as 450. There also are 20% pots floating out there, and that you just never know what you're going to get. Now, there are other values of pots, and there really is no wrong choice. It's just what sounds good to you. I hate to call it a rule of thumb, but I'll use that phrase. The higher the resistance, meaning where it's like 250K is 250,000, is a lower resistance than a 500K or 500,000 ohm pot. Is the larger the number, the more highs, if you will, the brighter it's likely to sound with the same set of pickups. There's lots of other variables, but we'll just leave it at that. So if you think, well, I like a really bright sounding guitar, go ahead and use a 500K pot. Doesn't matter what the pickups are. It's often said you have to use 250K pots with Tele single coil pickups. No, you don't. You can use whatever you want. You're building a Gibson style guitar with humbuckers, you have to use 500K pots. No, you don't. It's a great place to start, but you may find over time that you prefer different values. Okay? Just quickly, how they actually work so you understand it is, regardless of the value of the pot, 500K, 250K, 300K, that doesn't matter. You're only going to see these three lugs. One is going to be used for the input, meaning it's the signal coming from your switch or from the pickup. One lug is going to be for the output, usually to the output jack and out from the guitar. And the third one is a ground lug. The way I've got this multimeter set up is I've got it set for the way you would normally see a guitar wired, where this lug is the input, meaning the signal coming from the pickups, whether it's through the switch or direct from the pickups. In the middle is the output to the jack. And I've, if you will, thought about it, okay, if this is the front of the guitar, I've turned the volume all the way up. So you can see over here the resistance is reading 0, meaning it's all the signals going directly from whatever's coming into the pot and then going out to the output. If I'm thinking about turning this down, oh, you can see the numbers, it's going up. That means there's more resistance to the signal going from the input to the output. That means more signal is going to this lug, which is the ground. And all pots work that way. There is a thing called taper. This is a linear pot, which means if I turn the knob so it's about halfway through its travel, it's going to read about halfway through its total value. An audio pot taper is more of a curve, so that if I'm thinking about, okay, here again, here's the front of the guitar, I've got the volume up all the way. I turn it a little, there's going to be a pretty big drop in volume, as opposed to if I have it all the way down and want to swell it up, it's going to be more gradual. So that's mostly personal taste. I like to use linear pots for volume and audio pots for tone, but do what works for you. Again, there's no right or wrong, it's just a different feel. And how you like to use your onboard, the guitar controls. The other thing is, just physically, the two types of brands, I should say, of pots you're going to see most often are alpha. This is an alpha pot, and CTS pots. Now, one is, and I've done this deliberately, you can see this is a long shaft. It's called a long shaft pot for like a Les Paul that has a thick carved top. It's just so that it can get through that thick top. When this is a regular shaft alpha pot that's made to go on things like, lo and behold, the Telecaster control plate, or a pick guard on a Stratocaster, something like that, where it doesn't need all that extra metal. I will tell you, though, they're not the same thickness. That alpha pots are considered what's called metric pots. So it's about 6 millimeters, the threaded part across, so that happens to be an old control plate, that fits on there no problem. If I try to do it with the CTS pot, which is a thicker, a thicker shaft, that's not going in there. Be aware of that. The other thing is, you know, people like to dress up their guitars with different knobs. The same knob will not fit on these two pots. That the first thing to look at, yes, they're both, let me just get one out of the way. They both are what's called a split shaft. You can see that. But this is what's considered a coarse spline, so that if you counted the little ridges, there's 16, and because of the slot, there's a couple missing. So you'd be looking at coarse or 18 spline knobs. And on here, same way, they're closer together. So there's 20 splines on the end of the pot, and they're considered fine splines, which is 24 if you're looking at the knobs. It can be very confusing, but short version is coarse knobs will fit on the alpha style coarse tops, and fine knurl knobs will fit on the CTS style, imperial style sometimes they're called, or US style tops. Obviously there's also solid tops and some other things. But it's just trying to get those components to match. There's nothing like spending the money on a component and realizing it won't even physically fit in your guitar. One more quick thing about potentiometers on a control plate for a Tele is the route, meaning the hole in the body that this is going to set over, is not really wide. So what I like to do actually is to use, these are called mini pots. The values are the same and the taper and all that, but you can see physically the pot itself, the casing is smaller. You certainly can use, and I'm going to on this one, use full size. These are alpha pots, but there's not a lot of extra room. So when you mount them, you want the lugs to face each other. If you try to put it like that, it will not fit in the route in the body. Okay, so I've got my plate, I've got the two pots. I'm going to need a capacitor to roll off high frequencies from the tone control. I'm going to use one that looks like this. Again, there's a lot of voodoo here, and people will spend huge money on paper and oil capacitors and swear they're so much better than this, that, or the other thing. The value means way more than what it's made of. And the two general styles are this. We can see there's a lead coming out of either end, and this style, like that. I think you can see. It's a small one, where the leads go like that. But you certainly can bend them, and you're going to need to carefully. And the way they get mounted varies, but they all work the same way, is that they're going to bleed off a certain amount of the high frequencies to ground as you turn that tone control down. So you're getting less and less treble. Just like the volume controls, it's passive. It's not going to add anything. All it can do is take away. This happens to be a 0.033 microfarad is the unit that they use, and this is a 0.047. The way to think of these is the larger the number, the more treble it can bleed off. So, for example, there are also 0.022s that are often commonly used in something like a Les Paul, where it's bleeding just a little bit of that, you really got to crank it all the way down to zero to get a lot of the treble off. And it's done just to cut a little bit of if it's a really overly bright pickup. Single coil, since they typically can be a little brighter, often people will use, the classic is a 0.047 capacitor with a 250K tone pot. I find it makes them muddy. I like a 0.033. I split the difference. But again, there's no wrong choice. It's just going to color your tone a little bit differently. And if you're running with your pots all the way on 10 all the time, you're going to really notice less and less of a difference depending on what you choose. Okay, so we've got the two pots. I'm going to use the 0.033, so I've got my capacitor there. This may be the simplest choice. It's a standard, it's literally a Fender, a three-way blade switch. They're simple, but you can see, wow, there's 1, 2, 3, 4, 5, 6, there's 8 lugs in the back. Wiring that is probably the most finicky piece of the whole process, which we'll get into later. But I've got the switch, so the switch is good to go. I'll just set that there. Another pretty standard one is the 1/4-inch jack. You can buy different brands, and sometimes you can get ones where this piece here is longer or shorter. You can also get them stereo. All you need is a mono 1/4-inch jack. They're pretty standard. I do happen to like Switchcraft, which is what this is, so that's ready. The only other real component that you have to use is wiring that's connecting various components. And you've got wiring coming in obviously from the pickups. So let me just pretty quickly talk about wiring that you're going to use. One I'm sure you're going to see is this is called pushback wire. This is kind of a cloth, and you literally can shove that down with your finger and you'll see, oh, there's the wire that you're going to be soldering. You're very likely this is what, especially if you're looking at Tele style pickups, you'll see 2 wires coming from the pickup. Usually one is either this color or white and the other is black from the pickup. Okay, and you can use it yourself. The one thing I don't like about it for components is it's pretty stiff and big, and especially in the Tele you don't have a lot of room. But that's the pushback cloth wire. 2 we won't use, but just to show you, you do sometimes see, especially with pickups, especially if you got a humbucker and it's a 4-wire humbucker, is these, again, which are thick diameter and fairly stiff, that these are shielded cables. So this one you can see, I think, is that there's 2 leads in here, a red wire and a red wire, and the whole thing is covered in this braiding, okay, to shield it, to cut down on noise being picked up by the wiring. And some pickups will literally come with this kind of a setup, where you've got 4 wires in a plastic cover, again with shielding here. And again, you're going to need the biggest hole to get the wiring through. It doesn't bend around really easy. We aren't going to use it with the Telecaster. This is a braided single conductor pushback wire where you can see this is the shielding and it's also the ground. Very common in older Gibson style guitars. Builders still use it. It's fairly flexible for its diameter. The one downside or upside, depending on how your wiring is, since this is the ground wire, if you will, is exposed. So if it touches something that you don't want it to touch, it's going to ground it out. I don't recommend it for newbies. We're down to probably the two choices, and I'm going to use a little bit of both for this build. One is typically the wiring used to connect components inside the guitar is either 22 or 24 gauge wire. The smaller the number, the bigger, the thicker the wire. So like what's in your house is typically 10 gauge or 12 gauge wire. That's pretty thick and stiff. In a guitar, it's only millivolts of electricity going through there. You don't need that big thick wire. So you've got, this happens to be 22 gauge stranded wire. You can see it's like hair, all the little strands there. Works very well. I like the stranded because it's really flexible. There's also solid core wire. This is the same gauge, but you can see there's just one solid piece of wire down the middle. This is stiffer. It can be good in some places if you go, well, I need it to bend like that and stay that way. It will. Okay? And then the last one is things like the leads from the pickup where you've got the two wires coming in. Often from the manufacturer, they will just be kind of loose, two wires. I don't have a pickup in front of me, but you know what I mean, that there's two wires just kind of side by side coming out of the pickup like this. There's no shielding to it. If you twist them together, the ground wire really kind of acts as a partial shield for the hot wire. And you can even buy that, pre-twisted, which is what this is. So again, this is a little bit finer. This is 24 gauge stranded wire. I will be using this for the output. So that's all the components that we're going to use. 250K pots. I'm actually using a linear for the volume and an audio taper for the tone. I've got a 0.033 microfarad capacitor for the tone control, standard Fender three-way switch, standard Switchcraft 1/4 inch jack, and a bunch of wire. As I prep for my soldering, obviously I have to mount the components, the potentiometers, and the switch to the control plate here. Just a quick note is you want the exposure, meaning how far this is sticking out from the plate, the same for both potentiometers. And typically you don't want it too tall or your knobs are going to be way off the top of the guitar. Is where I like to set it is so that the nut that's holding it in is just one or two threads down from the top. So you've got the body of the potentiometer and a nut and a lock washer, and on the outside you've got the dress washer and another nut. I can adjust using this open end wrench. I can slide that in there and tighten up that inside nut so that these stay the same. Let me take a minute before I actually start soldering to talk a little bit about tools, very briefly. Obviously you need a soldering iron. Minimally it should be one that you can has a holder like that rather than just a loose soldering iron. They're a pain. The other is, this is a fairly simple one. Let me turn it around so you can see it. And it is off, by the way, so I don't get burned. Besides the on-off, it's adjustable for the heat. Typically, I'm somewhere on this one between 350 and 400 degrees. You want it hot enough so that it melts the solder pretty quickly, so you're not damaging components, is the short version. I'm going to say two more things about soldering irons. One is, like this one, again, let me get it in the middle here where you can see it. You can see this has the sponge here on the in here, and they often come with this. The problem with using the sponge to clean the tip of your soldering iron, a wet sponge, is that every time you do it, and you'll hear it go, shh, when you touch the thing, is you're cooling off the tip. Not the best way to do it. What I prefer to do to clean the soldering tip is, this is an old can, you could use like a tuna fish can even, and these are these, I don't know if they're called chore boys or scrunchies or what they are, but they're just literally at the grocery store in the cleaning supply aisle. They're just copper. And I've shoved 2 or 3 down in there so that if I need to clean the tip of the soldering iron as I'm going, because it will get gunk on it, I can just stick it in there and spin it a little bit and pull it out, and it'll be perfectly clean. The thing is about the tip, let me bring this up there so you can see it. Get it right there, I think you see it the best. You see it looks like a pencil. You need a fine tip on this, not a big wedge, in order to get into the lugs on the potentiometers and so on. That's your best bet. Okay, that's the soldering iron and cleaning the soldering iron. Okay, then a word about solder. And I'll bring this up here. Is you want to use lead-free. Otherwise, I don't know if you can still get lead solder with lead in it or not, but it's lead-free. This is, I believe, either 98 or 99% tin. I'll put it up on the screen. And then it has just a little bit of silver, less than 1% of silver and copper to it. And this also has, you can see it down here, flux 2%. That helps it melt and adhere to whatever it is that you're soldering. And the actual diameter of this is 1 millimeter. I don't like it any thicker. It's just too globby. It's hard to get it where you want it. I believe they actually make a thinner one. I've never used it. 1 millimeter is a great size for this type of electronic soldering. Okay. Something you're going to find as you're working is you don't have 3 hands, so you've got a soldering iron in one hand and you've got the solder in another, and whoa, how do I hold the wire against the lug or something? One of the ways is you can get all sorts of varieties of this. Let me turn this sideways so you can see it. It has these articulating alligator clips, so you can bend it around any way you need to hold the wire or hold a component, that type of thing, while you're working. A few other small hand tools. The most useful one is, and I'm going to go like this, is that I don't very often do, if you will, brand endorsements, but these have been great. It's a General number 69 wire stripper, and it goes from as large as 12 gauge to as small as 26 gauge. Since most of the wiring you're going to come across in a guitar is 20, 22, 24, and even 26 every once in a while, and this is highly accurate. And I've had this one I think I'm on build number 92 at the moment. So I've built over 90 guitars plus other projects using these, and these are still in great shape. Can't recommend it enough. And you're going to need some sort of good wire stripper. These are just like a little pair of nips. You obviously can use them to cut off a piece of wire, but sometimes you'll have a little extra lead you want to clip off, or even a little glob of solder or something. This will snip them right off. You can get all sorts of different, Amazon, Lowe's, Home Depot, wherever you want. You're probably going to find a small pair of needle nose pliers handy for holding things or moving things. And lastly, a tube of, let me hold that up, I think you can see that. There we go. The rosin flux pen. Rosin flux, again, it helps the hot solder spread and adhere to whatever you're using. You won't need it for most components, but when you get to something like, let me just show you the one that I've already done, is you can see right here, I had to, so it doesn't glare, I think you got it there. I had to put a blob of solder on the pot. That's actually a pretty big chunk of metal, so it will take a little bit longer to heat up. It helps it heat quicker and spread that solder onto a bigger surface like that. I guess last one, rather than waiting until you've got the whole thing done and buttoned up, and you think it's fine, and then you plug it in and realize, whoops, I screwed up something. A very inexpensive digital multimeter, but it lets me, most especially lets me check for continuity, meaning is there a signal going between those 2 points the way I want it to, and for resistance, which lets me check, since I know what the pot values are supposed to be and what the resistance of the pickups are supposed to be. I can verify before I ever button up that guitar and put everything together on it that yes, all the components are soldered correctly and I'm getting the values that I want. Okay, just wanted to very quickly revisit the diagram. This is exactly how I'm going to wire it up. So you have the three-way, and here's kind of a completed one. So you have the physical and the diagram. So you've got your three-way switch with the leads coming in from the neck pickup and the bridge pickup, and then the output from the switch goes to the input lug of the volume potentiometer right here, and the middle lug then is the output to the jack, and the third lug over here is the ground lug. Then this one is the tone pot, and you can see it's jumper to the input lug of the volume pot, and then the capacitor, rather than just grounding it to that back of that pot, is brought over here to the ground lug of the volume pot. Exactly the way I've wired it. The only difference is this says a 0.047 microfarad capacitor. I'm using a 0.033. A note about grounding. You're grounding for two reasons. One is you can't complete circuits without them being grounded, and second, it's for shielding, to shield your guitar from picking up noise from fluorescent lights and even hum from being plugged, the amp being plugged into the wall and things like that. This one actually says that it's assuming that you're mounting these on a metal plate like this, and once you do that, that creates the ground for all this. So you do not have to wire an extra jumper wire to ground things. The plate itself serves as that ground. So this is a diagram of a standard Fender style three-way blade switch. You will see, if you're ordering switches, especially on places like Amazon, there's something called an import switch, where rather than having, a lug kind of either side here, there's one strip. The pinout on those is a little different, but they all function in the same way. And I'm going to show a close-up of the actual switch here so you get the idea that one side, these four lugs, have to do with the neck pickup, and the other side has to do with the bridge pickup. You can see one side is kind of a solid metal side, and the other one is, you can see the open edges. It doesn't matter which way you mount this switch before it's wired, obviously, is it can mount with it on this side or spun around so it's on the other side. That doesn't matter. This side, though, you're able to see how it works. So the way this is going to be is the neck pickup's going to be connected to this lug. And as I move the switch, can you see the metal there, the wiper moving? So that if I'm all the way in what would be the neck position, okay, that this is connected to that part of the output. This is the output wire. So it's going out to volume controls, tone controls, and so on. If I go in the middle, you can see it moved up one. It's still connected to the output, but so is the bridge pickup from the other side. And if I go to what would be, you're selecting just the bridge pickup, you can see it's connecting to this, which has nothing on it, so you don't get any signal. And you can't see it because of the plate, but on the other side, for these, those are the connections for the bridge pickup, and they're just backwards. So you get the opposite effect when you move the switch. That's why you have this weird looking output wire that has to go in there. And that's what I'm going to show you next, how I like to wire that up. Okay, just about ready to get going with the soldering here. A quick word about soldering. I'm going to call it style. Many, if not most, modern tutorials you'll see on YouTube, especially related to things like soldering guitar components, you'll see what they'll do is they'll take the soldering iron before there's any components here, and they will literally fill in the lugs, say on the volume pot, with a little bit of solder. And then when they go to, say they needed to solder, a wire into this lug, there's already solder on it. They heat it up and they push the wire in and let it go. That works fine, but what I use is literally traditional old style military spec, which says it has to be mechanically connected, that the solder is just to enhance the electrical connection. It is not there to hold the component in place. You can see I've not just put it through the hole in the lugs, but I've looped it, that's held in place. It's not going anywhere. This circuit would literally work. There's contact there. There's physical contact. Same way the capacitor, where it's going, is already in place. I've already put the wire in place. The output wire for the switch is in place. All these are good electrical connections now. The solder is just to enhance the electrical connection. So I am a big advocate for old military spec. It's got to be mechanically connected well before you solder it. The other nice thing about that is other than, basically I just have, other than the output jack, as far as these components go, I just have the wire going from the output on the switch to the input on the volume control. Everything else is already in place. And the only reason this isn't is because this is stranded wire, so I do need to pre-tin the wire. This is solid core wire. This is solid core wire. Obviously, this is the ends of the capacitor are solid. I don't bother to pre-tin those, but I do pre-tin wire that's stranded. So, for example, you can see how it starts to separate. By hand, I'm going to twist that a little bit so that it looks straight. And then I'm going to heat up the wire and let it absorb some solder so that it's like it acts like a solid core piece of wire. For Telecaster standard wiring and jack location and so on, the output wire no shorter than 6 inches and no longer than 8. So 7 to 8 inches is plenty. You don't need a lot of extra wire flopping around inside the cavity, but you want it long enough so that you can fish the jack through and pull it out a little bit to attach, have a little bit extra space to attach to the whatever kind of jack cup or jack plate that you're using. Okay, so I'm just going to get a little solder here on the tip of the soldering iron, and you just set it up against the wire. You're heating up the wire, and it will actually got a little extra on there. And pull it right off. But that's now going to act like a solid piece of solid core wire. Okay, that one's done. All that preparation, and now we're ready to go and solder this up. And I'm going to start with the switch. And I've already got placed in there, you can see this, a little bit of yellow there. This is connecting there are 4 output lugs. Okay, and I deliberately like to do it this way. You'll see sometimes someone will do it with a piece of wire that has no insulation on it. Is you want to be sure that there's nothing touching this lug and this lug. Otherwise, if you just wanted the bridge pickup, you may suddenly find, wait a minute, the neck pickup's also being energized. So I like to take a piece of solid core wire. Here's a little tiny one like this, strip most of the insulation off, and then I can bend it around whatever shape I want, go through the hole in the lug, come around to the other one, bend it down. needle nose pliers are really helpful for that if I need to take just the end, you know, and bend it around so it looks like that type thing. It's fiddly, takes a few minutes, but it's worthwhile. And now it's not going anywhere. So all I now need to do is give a really secure electronic connection by soldering those. Okay. At the very end, and to show you how that mechanical connection is easy to do is, so here's my output wire, which is going to go from the final output lug of the switch to the input lug of the volume pot. All I'm doing is, so you can see is that these little tiny, there it goes. And you can use the needle nose, and sometimes you can just use your finger. I am just bending that around, almost like starting to tie a pair of shoes. So you can see this is not going anywhere, and this should go quite quickly. So I'm just going to put that there. There's that one. There you go. That's the best way to do it, where the iron is underneath and the solder is on the top. And I'm also trying to do this so I'm not blocking the camera. This is where having that really narrow pencil tip really comes in handy. Okay, those are all set. And then the little snips, where I have the extra big piece of wire there, I can clip off. Anything that might inadvertently touch something that it shouldn't, I'll snip it out of the way. All right, so these 1, 2 on this side and those 2 on that side are the output lugs. They're soldered on there. Nothing's dripped down where it shouldn't. And now I can run this side over. And again, there's already this wire in here, so it's very easy for me to slide that through. Okay, so I've got the, again, I can't pull it out of there. I can even go a little tighter than that. I should do it a little tighter than that. Okay. Same way with that side. And I've kept this deliberately as short as I can. The shorter the wire is, the less extraneous signal you'll pick up. Okay? So this one's ready to solder, and that one's ready to solder. Same way, what I'm looking for is a nice shiny solder connection. I can go in there and just snip off the extra little bit. So now, if you think of the signal coming in, and let's use the neck pickup for example. The neck pickup is going to be connected here. The signal from that pickup will be outputted from here, goes to the input lug of the volume pot. Okay, I'm going to wire in. This will go from the output lug to the tip lug of the jack, and then this will go to the ground lug of the volume pot, and then the last thing I'll do is the capacitor. And what's helpful is sometimes if you put a little bend in them like that, so that's the output. I'm using the white wire. I always like to use, if I have a wire that's green, then think green, the G for ground. There it goes. Okay, just pull it up out of the way. Carefully get in there with the soldering iron. And this one, before I do that, let me show you the pot. And this is getting, I'm going to ground the back, that little body, the back of this pot will be grounded. And it's for two reasons. One is I need to ground this lug, but it also then, because this is physically connected to this plate becomes an electrical connection. So this now grounds this pot, and it grounds the switch, and it actually will ground the bridge in the end. Since this is a pretty big surface area, I'm not going to just try and use the soldering iron with a little bit of solder. That's where I'm going to use the old, rosin flux pen. And you don't need a lot, but right where the two we're going to touch, I'm going to probably can't see that because it's almost clear. I'm going to lay this soldering iron down against that pot right where the wire is touching. So now you can see it starting to pool. You don't need a ton. Okay, so that's now, pot is now grounded, which means all the physical parts are grounded. The other nice thing about this is that you can see this extra little loop here from the capacitor wire is it gives me places to, when I bring the pickup wires in, each pickup has a ground wire, I can connect it to there. And I've got to add this wire. So I'm going to do what I just said. I'm going to literally loop it around here. Take the needle nose, twist it around, so that's connected. The biggest danger in soldering is overheating something, and capacitors are probably the most susceptible to that. So this is just a little clip. You can even use an old alligator clip. This acts as a heat sink, if you will, so that it takes away some of the heat that's trying to go inside of that capacitor while I'm soldering this connection. If you're quick, and I've gotten good enough, I think, where I'm quick enough, but if you're not, you definitely want to have a heat sink. The other piece of equipment that I don't have running because of the noise, but I normally would if I haven't already mentioned, is a small fan. The fumes are a little nasty. So the pot is now grounded to the output jack. The lug there, the ground lug, is also grounded. The capacitor is grounded, so that the way the tone control will now work, as you can see, it's connected to the input. Here comes the signal from the pickups. It's going to the input side of the volume pot, so that as you turn the volume pot, some of the signal is going to the output, just going out to the jack, or some of it's going to ground, so you're losing volume. This works almost backwards, if you will, because the capacitor is like a filter. It only is going to work on certain high frequencies. It's almost like a volume control, but only for certain high frequencies, is one way to think about it. And again, these are both, this is passive. There's nothing powering it, so all you can do is cut. I can cut high frequencies, but I can't boost any. I can cut the volume, but I can't boost the volume. Okay, all right, last connection here. So you can see I can do it pretty quick like that. I'm not worried about burning that capacitor. And just to be a little extra neat, yep, I'm going to do that little end piece. So here's the output wire, and I've got to wire it to the jack. And there's two lugs. And if you look, you can see one, very obviously, there's all this metal here. That's the ground side. That's connecting to the body of the jack plug. And then this one, where there's looks like there's a space, that's what's being connected to the tip here when you put a jack in. So I want to go white. Let me bend these a little bit. Make my life easier. I want to go white is the hot wire to the tip, and green is the ground wire that's going to the main shaft, if you will, of that output plug jack. You want it to also, since you think about it, you're going to be plugging from the bottom. You're going to have a plug coming up through here. You don't want to have anything else touching. I will even sometimes use a little bit of shrink tubing. Come on. Here we go. I've got the iron on the back and the solder on the inside, where I can watch it fill the little hole completely. Nice shiny. So now that's done. So this is now wired and ready to dry fit into a guitar, and when the pickups are installed, very easy for them to wire up. Okay, I think we've covered it.